Hello again, everyone. Mr. Anderson coming to you with section A.1.8, and today we're going to get to the bottom of solving an equation. Many of you could probably sense that this was coming. It is the appendix, and we are to the second to last section, and we'll answer the question, what do we do if both sides are equal? We've spent quite a bit of time talking about the happenings of, how to put it, which side is bigger. We've focused on legal moves. We've done a lot of things that have set us up to be ready to tackle what we're about to tackle today. And the review of these moves is going to come in A77. So I'm going to ask you to join me here. A77, we're going to just spend a tiny bit of time talking one more time about which one's greater for the purpose of reviewing our legal moves with algebra tiles and maybe the how we could record that. And then we'll move on and talk about equation solving, right? So here we go, A77. I've got this pulled up already in the book. I can click on the A-77A tiles, and it's going to bring this to my screen in a new tab. And the legal simplification moves are going to help us figure out which one's bigger. I'm going to go a little quicker than normal through this one. The point is to review the moves. So I start, oh, there we go. I start with bringing the bottom to the top and flipping the sign. And I'll do this on both sides. Notice that I did the right side first. There's no real reason I did that. I just did it to be different on this particular one. So I've brought them all up. Now I'm going to cancel these zero pairs. Right, and I could be documenting. I'll just go to the right and cancel one. I know I'm not done with the left yet. I'll cancel this one. Let's see, I see another one over here. Okay, I got another one right here. Okay, and maybe I just spend a little bit of time reorganizing these. I've got what appears to be -3 right there. I've got another zero pair there. I cancel that out. Okay, so I've got -3 on the left, 0 on the right. So this turned out to be -3, and this turned out to be 0. Pretty clear that 0 is bigger than -3 there, right? And we could, of course, this right here is the opposite of -x, so I could write that like that. And then, of course, this right here is just a -x, and maybe you're the kind of person who's doing some recording along with this. You might then take a second as we bring that bottom one to the top. You might say, okay, I'm going to rewrite that and bring the bottom one to the top. Okay, that's changing that sign. All right, so I've got -x and a +x. All right, now what do those two make? Those two make that zero pair and cancel them. That might be one of the things that you're doing because you're already to that stage. You're recording that work, and that's a good thing. So keep that up, okay? But the focus, of course, is to use those algebra tiles to help us. Some of us, though, are going to be ready to move on without the algebra tiles, and that is totally fine. All right, so we've got those legal moves fresh in our mind again, and we've got a situation here, and this is the thing we've been working towards, but we're going to start with A and B. We've got x on the left, and I'm going to zoom in here. X on the left, on the right we've got 5. So this over here is just an x. We don't know what x is. And we don't know what, we do know what 5 is. But right now we can't answer the question. We can't answer the question which is greater. I've got to emphatically put that question mark there, right? Because x is a variable. It's an unknown. Okay, but let's go over here and check out these prompts. If the expression on the left is smaller than the expression on the right, well, that means, okay, smaller than. If that, okay. Then what does that tell us about x? Well, that means x could be 4. It could be 3, it could be 2, it could be 1, etc. Now I'm only using integer values here, but obviously there's decimal values that would fit in there. Okay? What if the expression on the left is bigger than or greater than the expression on the right? What does that mean x could be? Well, okay, that means that x could be like 6, 7, 8, 9, right? So that given information tells us about possible values of x. But now C, like I said, this is going to be the focus of our work today. What if the expression on the left is equal to the expression on the right? There is when this is the the one unique thing about problem solving that allows us to do some of the algebraic manipulation that we're going to focus on today and problem solving. Then we know that x and 5 have to be equal, or x equals 5. We have a solution or an equation that gives us that answer. Okay? But today, as we get into doing this solving, we're going to be using a new kind of thing called an equation mat. And thankfully, CPM has built some of these things for us, okay? So let me show you what we're going to do. It's going to look very, very similar to this right here, except it's going to look slightly different. It's going to look like this, okay? It's going to have a little double bar in the middle. I'll talk about that in a second. But if you guys would find A79 in your book, all right, we will talk about those inequalities later as we move on into other things, later in the course. But we're going to go ahead, and if we were in person, I'd hand you an equation mat. But because we're not, we're going to click on the A-79 A tiles, and we're going to do some simplifying. But our simplifying is going to be, well, it's going to require a little bit of extra focus at the end, and I'll explain why. Okay, I click on it, and here's something that pops up. This is the problem that they had built in the text, and our moves are going to be the same. But notice, instead of a prompt in the middle or a question in the middle saying which is greater, we've got this double bar. Think of that double bar as your equal sign. Okay? That double bar is the double bar turned sideways. That's like our equal sign. This is an equation mat. So they're telling me, hey, this stuff on the left equals this stuff on the right. And our goal, right, you saw me highlighted at the beginning of the lesson, was to be able to solve for x, and that's where we're going. So let's use these legal moves. Let's see what we can do. I'm going to start by bringing the stuff on the bottom to the stuff on the top. Okay. Excuse me. All right. Nothing too crazy so far. Everything is, maybe pretty similar to the way that it was. Okay, you can see I've kind of lumped a couple zero pairs together, so let me get rid of those. All right, do some canceling there. All right, the next thing that I might try to do is I might try to identify, I might try to identify stuff I've got on the same side, do some canceling there. Okay, so those are gone. All right, if I have an equation mat, let me throw a fourth legal move at you. Okay, check this out. I'm just kind of lining some things up for the purposes of my own organization here. Here's the additional legal move that we get with an equation mat. We're allowed now, because we've got an equal sign, to take these items. And remember how we had them on the bottom? We could bring them to the top, and we could change the sign. We can do the same thing if we bring them across the equal sign. There we go. Okay, so I've got this, and I'm going to drag it over here, and there we go. Okay, now look at what we got. Over on the left, we've got 2x, and over on the right, we've got 6. I'm just going to take a second, and I am going to write that. I'm going to write 2x equals 6. Now, some of you know what the solution is going to be here, but let's talk about what that solution is going to be. We're focusing on integer solutions right now to make the math with the equation mat manageable. But we would, if we were solving this, we'd divide both sides by 2. We divide by 2 on the left, divide by 2 on the right, we get x equals 3, we're in good shape. The same thing can be done in an equation mat. We can divide these, and you kind of see I set this up already, into 2 distinct piles. Okay? I've got this over here on the left, separated with a row of tiles on the right, and same thing here. And what I'm going to do then is I'm going to eliminate one of these as it's a copy. It's a carbon copy of the other. And what do I have here? I have x equals 3. And let's take a peek at that work here, right? Here's my solution. X is going to be 3, and that process is just the division by 2 process. And sure enough, 6 divided by 2 is 3. So there's another benefit of algebra tiles, and algebra tiles specifically for the purposes of solving an equation. Here's what I'm going to ask you guys to do with me. I'm going to ask you guys to do one more of these with me, and this is A-80. It says, now apply this new skill by building, simplifying, and solving each equation below for x. So I've got 3x minus 7 equals 2. Here's what I want you to try. Pause your device, open up a blank set of algebra tiles, find the equation mat, and build this, I'm sorry, not expression, build this equation. All right, go ahead and pause. Okay, hopefully you gave this thing a pause and a build. If not, you should really be trying these things. They're really going to be helpful tools. The build might look like this. Now there's another way you could have built this, right? Some of you maybe started with these up here, but let me talk to you about what I did. I've got a 3x, it's positive, that's why I've just got 3x up here. I'm taking away 7, so that's what these look like right here. This is 7, it's being subtracted. That's on the left-hand side of my equation. Then over here on the right-hand side, I've got a positive 2. Now let's talk about what the solution process looks like. Let's show our work, and we're going to try to connect the two. I'm going to start by taking all 7 of these and bringing them to the top so I can work with them. Now if I do that, I'm going to do something like this. Okay, now what does that look like over here in my work? Well, that's effectively taking this, and I'm just going to show my work down here, maybe. That's effectively taking this and flipping that sign. So I can write it as 3x plus the opposite of 7. And it doesn't matter to me if you put that -7 in parentheses. Some of us, know well enough that that is not the, how to put it, not the only way you can write that, I guess. Okay, but just flopping that sign, and maybe that helps us see that we're going to need to make another move with that. And if doing so helps you see that, then it is a positive thing to do. Okay, so we've got 3x plus the opposite of 7 equals 2. Okay, well, okay, now what do we do? I don't have any 0 pairs over here. I don't have any 0 pairs over here. But what I'm able to do is I'm able to use that move that we just talked about. I'm able to take these items and I'm able to bring them across over here to the other side, as long as I flip that sign again. All right, well, let's do that. Let's see what happens. I'm going to take them, I'm going to bring them over here, and I'm going to try to line them right up perfectly, and then flop those signs. Okay, now this is starting to shape up. It's looking pretty good. However, what did we just do, and how do we show that? Okay, well, this is effectively adding that 7, or adding the opposite to both sides, right? Adding the opposite of -7, and you may have seen the work done like this. Now, I didn't bring out 7 new tiles onto the left to do the canceling, to create all those 0 pairs, but I could have. All right? Easier for me to take those and drag them to the other side, and you can see what we total and sum over here, and I think you're going to find that 2 and 7 make that, right? So the only thing that's left here is 3x, and then over here on the right is now 9. All right, so we've got 3x, we've got 9, and now it's going to be, let's take these items and let's cut them up into 3 distinct copies of each other. And this is going to go pretty quick, and some of you might be racing me to the finish, and that's okay. All right, now look at what we got. I've got 3 distinctly, carbon copy rows, I'm sorry, not distinct, 3 identical rows. All right, x and 3, x and 3, x and 3. I'm going to get rid of these copies, and by dividing those tiles on the left and dividing the tiles on the right up into 3 groups, I've done this step, the division step, and you all know that our answer is 3. Okay, check this out. We've got an answer. Our answer is 3. We do want to check this answer if it's a homework problem. You can check that via homework help. But you can also, and if we don't know this, let's learn it and then start practicing with it. We can also take and plug in and check that answer, see if it works out, right? We can do this mentally. We can do this with calculator. We can show our work. We can ask ourselves, hey, is 3 times 3 minus 7, does that equal 2? And I think the answer you're going to find is absolutely. 3 times 3 is 9. 9 minus 7 definitely is 2. So that answer checks out. All right, here's what we're going to do. We've got a math note that is probably a good thing for your notes if you want to add that. But this is in the CPM ebook A.1.8. It's right below that last problem, A80. But we've got some review preview, and there are 4 review preview problems. Okay, use a calculator, check your work, check your answers, but try as hard as you can to document that work. Okay, thanks for watching. Everyone have a great day.